Welcome to the module, Marzano's 9 High-Yield Instructional Strategies for K through 12 Instructors, Part 4. We value your time and appreciate your active participation during this module. Here are a few suggested learning norms to make the most of your time. If possible, work in an environment with as few distractions as possible so you can engage and reflect, take notes and jot down ideas and questions as needed, and lastly, use this time wisely to ensure your professional learning with university instructors is productive. Here is the agenda for this module. Learning objectives, review of strategies 1 through 5, strategy 6, summarizing and note-taking, strategy 7, homework and practice, strategy 8, identifying similarities and differences, strategy 9, generating and testing hypothesis, and summary of learning. Here are the learning objectives for this module. By the end of this module, participants will examine the final 4 of Marzano's 9 research-based instructional strategies in depth that positively impact student achievement, and understand various methods for teaching each of those strategies. Marzano's first 5 instructional strategies, discussed in Part 3, provide research-based approaches to enhance student learning across K through 12 classrooms. The first strategy, setting objectives and providing feedback, emphasizes the importance of making learning goals clear to students and giving them timely, specific feedback. When students understand what they are expected to learn and how they are progressing, they can adjust their efforts more effectively. Objectives should be student-friendly and tied to real-world relevance, while feedback should focus on process and improvement, not just outcomes. For example, an instructor might say, "You've solved 3 out of the 5 problems correctly. Let's review how to approach the remaining 2 differently." The second strategy, reinforcing effort and providing recognition, helps students connect effort with achievement, fostering a growth mindset. Recognizing persistent strategies and improvement encourages students to continue working towards mastery. Recognition can be verbal praise, highlighting student work, or other forms of acknowledgement. For instance, an instructor could note, "I noticed you spent extra time reviewing your answers and your score improved. Great effort." Cooperative learning, the third strategy, involves structured collaboration that promotes deeper understanding and critical thinking. Small groups with assigned roles ensure accountability and meaningful interaction. Cooperative learning not only builds problem solving and communication skills, but also allows students to learn from one another. An example could be students working in pairs to solve a math problem and then explaining their reasoning to the group. The fourth strategy, questions, cues, and advanced organizers, supports comprehension and retention by guiding student thinking. Instructors use higher order and open-ended questions or prompts to check for understanding, provide cues to activate prior knowledge, and offer advanced organizers such as charts, outlines, or graphic organizers to structure new information. For example, before reading a chapter on ecosystems, an instructor might ask, "What do you already know about ecosystems?" and provide a graphic organizer to help students categorize information. Finally, non-linguistic representations involve using visuals, diagrams, models, and physical activities to reinforce understanding. These strategies help students make connections between concepts and support learners who struggle with text-based instruction. Examples include creating Venn diagrams to compare characters in a story, using flowcharts for science processes, or incorporating gestures and kinesthetic activities to demonstrate ideas. By intentionally using these 5 strategies, instructors can create engaging, effective lessons that meet diverse student needs and promote higher levels of learning. Having reviewed Marzano's first 5 strategies, we will focus the rest of this module on Marzano's final 4 strategies, starting with the 6th, summarizing and note-taking. Summarizing and note-taking promote increased comprehension because these tasks require students to analyze a subject in order to expose what is essential and then put that information into their own words. Students have to be taught how to summarize and how to take notes. To effectively summarize, students must delete, substitute, and keep some information which requires analyzing at a fairly deep level. Let's look at some examples you can implement in upcoming lessons. WBST framework is a simple but powerful tool to help students summarize fiction texts by identifying the key elements of a story. Using this strategy, students answer 5 guiding questions. Who is the story about? What did they want? What problem did they face? How was the problem solved? And what happened at the end? By responding to each question, students focus on the most important information and are able to retell the story in a clear, concise summary. This strategy supports comprehension because it encourages students to think critically about characters, goals, conflicts, and resolutions, while also giving them a structured way to organize their thoughts. Instructors can model the process with a read aloud, then gradually release responsibility to the students so they can use SWBST independently or in small groups to summarize fiction texts. Many students are able to identify the topic of a nonfiction text, but they often struggle to craft a complete and accurate summary. The 5 W's framework, who, what, when, where, and why, helps students focus on the key elements of a simple nonfiction text. By using this framework, students learn to capture the core facts without including unnecessary details, creating clear and concise summaries. For more complex texts, the IRIW framework, identify the main idea, recognize important sections, identify key details, and write a summary, can be used. Younger students can begin by distinguishing between texts written in chronological order, which retell events or steps, and texts written to explain a topic. Understanding the text structure helps students comprehend nonfiction content more deeply. In more complex text with multiple sections, students must identify the main ideas in each section and their supporting details in order to craft a well-written summary. Practicing these skills, identifying main ideas and supporting details, and then using them to write summaries, helps students develop stronger reading comprehension and summary writing abilities across grade levels. Another example is summary frames. Summary frames are a method for helping students to organize their thinking. Summary frames and other graphic organizers are often used to assist students who learn visually. This specific graphic organizer can be used with fiction and nonfiction text and can be used alongside one of the other frameworks, the SWBST, 5Ws, or IBIW, to help students focus on including only important information in their summaries. The chain of events organizer supports students with summarizing events in chronological or sequential order. So students have to understand these terms, and they must also understand that to form a chain, there must be a relationship between the events they include in their summaries. This further helps them to identify and focus on the important events only. Here is an example for upper elementary and secondary students. As you can see, it is more detailed and more in-depth, providing a richer analysis of the text. This example shows the level of comprehension and critical thinking that secondary students should aim for when summarizing complex nonfiction texts. Summary frames can also be a series of sentence starters that the instructor provides to students. These sentence starters are designed to highlight the critical elements for specific types of information. In this example, students are given a framework to organize their thinking. The sentence starters guide the summary of the important parts of a story. Practicing with sentence frames, students learn how to organize their ideas, link claims to evidence, and communicate their reasoning more effectively. Instructors can gradually reduce support as students become more confident, moving from structured frames to independent argumentation. Using sentence frames also encourages academic discourse, helping students participate meaningfully in discussions and debates while building critical thinking and writing skills. Webbing is a note-taking strategy that uses circles to indicate the importance of ideas and lines to indicate relationships. Lines from one circle to another indicate that the concepts in the connected circles are related in some way. In this example, the main idea to be explored is animals. Connected circles are labeled with 4 habitats: jungle, desert, forest, and house. Further connections and relationships are explored within each category with respect to what type of animals live in each of the 4 habitats. This example makes it easy to see how this strategy helps students to organize their thoughts and ultimately their writing. In this example, students use webbing to examine the main characters, symbols, conflicts, and themes in William Shakespeare's Hamlet. In this example, students are learning the terms point and ray. The first column contains the word itself, which helps students clearly identify the term they are learning. The second column asks students to write the definition in their own words, which encourages comprehension and ensures they are processing the concept rather than just memorizing a dictionary definition. The third column provides space for a picture or example, which reinforces understanding through a visual representation or a real-world connection. For instance, a point can be represented by a dot on a line or a location on a map, while a ray can be shown as a line with a starting point and an arrow indicating its infinite direction, like sunlight streaming from the sun. This strategy supports multiple learning styles: visual, linguistic, and kinesthetic, and helps students create notes they can revisit and study effectively. Let's take a look at another example: 3-column notes. In the first column, students write the concept or rule they are learning. In the second column, students capture an example of how to apply the concept or rule. Depending on the concept, the example could be solving an equation, like what's shown in our example, or it could be a graph or other visual representation. In the final column, students write an explanation of the concept or rule in their own words. First, the second column is labeled with an example of the concept. Notice that this example, the process has been displayed for future reference. And second, the third column provides space for an explanation and a purpose. Students write out in their own words the steps needed to solve the example. 3-column notes support students by helping them assimilate and categorize new information using their own words and pictures. This results in notes that are relevant and meaningful to them. Note-taking is a powerful strategy because it encourages students to record key ideas and supporting details, which helps them focus on what is most important in a lesson or text. This process supports both comprehension and long-term retention, giving students a reference they can return to when reviewing or studying. Note-taking can be structured, with instructors providing guided formats, or student-generated, allowing learners to decide how to organize their own information. It can also be integrated with other strategies, such as questions, cues, and organizers to deepen understanding. Using both visual and written formats like diagrams, charts, or graphic organizers alongside written notes further strengthens learning by engaging multiple modes of processing and helping students make connections across the content. No correct way to take notes. The most important thing about learning how to take notes is to find a strategy that works. Each student will have a different favorite strategy, so it's helpful to expose students to a variety of strategies. Ultimately, what's most important is that students learn to take notes, period. Whatever method or strategy they choose, the key is having information in their own words that they can return to later when they need to review and study. Note-taking strategies at the elementary level need to be explicitly taught, and at the early grade levels primarily consist of visual note-taking techniques. Here are a few elementary note-taking strategies to consider. A T-chart is a type of diagram used to compare and contrast features of a certain topic. This type of note-taking strategy is one of the simplest graphics that one can make, since it only consists of 2 columns, separated by lines that resembles the T. The box and bullets note-taking method is a comprehensive way to take notes that involves dividing a page into sections or boxes, each containing a main idea or topic. Underneath each box, students create bullets that represent supporting details or subtopics. This method allows students to easily see the connections between ideas, and it can be used for a variety of tasks, including note-taking during lectures, brainstorming for essays, or organizing ideas for a project. The reverse box and bullet method provides the bullets supporting details or subtopics first, and the boxing of the main idea or topic underneath. And number 3, concept mapping or webbing is a note-taking style that uses shapes connected by lines or arrows to show relationships between main ideas or topics, subtopics, and details. More examples include the following. Flow maps and timelines provide a linear way for students to capture their thinking, help students determine cause and effect, give students a sense of perspective, and show changes over time. Creating lists as a note-taking strategy is useful as the list documents what students might ordinarily forget. Memory strongly prefers internal structure, and without this structure, remembering is hard work. Unlike stories, in which events are connected by cause and effect, items on a list are only related to the main topic and may not be otherwise related. If you've ever had to compare and contrast ideas, there's a good chance you've used a Venn diagram. Venn diagrams are a simple way to record the differences and similarities between concepts, which might include ideas, subjects, people, and etc. Each overarching idea in a Venn diagram is represented by a circle. These circles overlap, and any commonalities are written in the area that overlaps. Effective note-taking helps students capture, process, and organize key ideas in ways that support understanding and learning. Remember, the method matters less than the act of capturing and organizing key ideas. The following note-taking strategies offer students multiple ways to capture and organize information based on their learning needs and the task at hand. Slide-based note-taking, or write-on-slide. The write-on-slide technique is a simple and efficient way for students to take notes. Students annotate directly on copies of the presentation or lecture slides, adding their own observations, examples, or clarifications. This approach promotes active engagement with visual content and allows students to interact with the material in real time, rather than creating separate notes. Brain dump note-taking helps students get all their ideas down on paper before organizing them. This method is especially useful for pre-writing, as it allows students to identify, categorize, and structure their thoughts. Starting with a brain dump can make the process clearer and more manageable. And the bullet method. The bullet note-taking method organizes information using headings and bullet points. It helps students group related ideas under clear topics, making notes easier to review and study. This approach is particularly effective for summarizing lectures, readings, or discussions in a concise and organized format. Reflect. Which note-taking or summarizing strategy could you try first in your classroom, and why do you think it would work for your students? How might you modify these strategies to meet the needs of students with varying readiness levels or learning preferences? Stop the video at this time to write down your thoughts. Possible responses for number 1, I would start with the write-on-slide technique because my students respond well to visual cues, and it allows them to engage directly with the content. I want to try the bullet method because it helps students organize information clearly and is easy for them to review before assessments. Or I might try concept mapping or webbing because it helps students see relationships between ideas and supports deeper understanding of complex text. And possible answers for number 2, for students who need more support, I could provide partially filled slides or structured graphic organizers, while letting advanced students create their own notes independently. Or I could offer multiple formats, bullet points, charts, or mind maps, so students could choose the method that helps them learn best. The next high-yield instructional strategy that we will examine is homework and practice. Homework provides students with the opportunity to extend their learning outside of the classroom. Given the findings that homework does positively influence the achievement of students, it is safe to conclude that all students from about second grade and beyond should be asked to do some homework. It is important to realize, however, that students at lower grades should be given far less homework than students at higher grade levels. In addition, parent involvement in homework should be kept to a minimum. When parents help too much, we never know the individual capability of that student. Plus, there are students who may not have a parent at home who can help with homework for one reason or another. It is recommended that parents facilitate their child's homework, which essentially means that parents are simply asked to make sure that their children have the time, resources, and space to complete homework. Research reflects a 30% gain in achievement when instructors make specific comments on homework. Assigning homework is only beneficial when it is reviewed, and students are provided with feedback. Students receiving a grade on homework also improves student achievement versus that which is not graded or does not include feedback. When assigning homework, it is important to identify and clearly articulate the purpose so that both instructors and students understand its role in learning. If the homework is for practice, the material should be very familiar to students, reinforcing skills and concepts they have already been taught. Assigning practice on unfamiliar content can lead to confusion and the formation of misconceptions. On the other hand, if the homework is for preparation or elaboration, students do not need a deep understanding of the material yet. In this case, homework serves to prepare students for upcoming lessons or concepts, giving them exposure to new ideas that will be explored more thoroughly in class. Clarifying the purpose helps ensure that homework is meaningful, effective, and aligned with instructional goals. Let's look at an example called homework assignment squares that you could implement in your classrooms. Squares are a simple yet powerful tool that helps students track homework, assignments, and deadlines. When used consistently, they also serve as an effective home-school communication tool. Each square clearly states the purpose of the assignment, outlines what students are expected to learn or accomplish, and provides any necessary background information. This structure helps students manage tasks, prioritize work, and stay organized throughout the school year. It's important to teach students how to fill in the squares early in the year. Many students appreciate the clarity that homework assignment squares provide. They know exactly what they are supposed to do and understand why the assignment is important, which supports both independence and accountability. Homework that focuses on practice and skill reinforcement helps students solidify what they have learned and track their progress over time. In math, students might complete a set of practice problems that build on the day's lesson and reflect on improvement across multiple attempts. This allows them to see growth and reinforces a sense of effort and achievement. In language arts, students could rewrite a paragraph using newly learned strategies for embedding sensory details, then reflect on how their writing improved from the first attempt. This not only reinforces skills, but also encourages self-assessment and metacognition. In science, students might label diagrams of the human body or chemical reactions and submit a self-assessment of accuracy when the correct answers are shared in class. This promotes attention to detail and helps them monitor their understanding. These types of assignments support reinforcing effort, providing recognition, and encouraging students to take ownership of their learning. Homework focused on note-taking and summarizing helps students organize and process information in a meaningful way. Students might summarize a chapter or a lesson in their own words, using bullet points or graphic organizer or a short paragraph to capture the main ideas. Another option is to annotate slides or class notes with additional examples or clarifying questions, which encourages students to engage more deeply with the content and make connections to prior knowledge. A third approach is to have students complete a brain dump by writing down all their thoughts about a topic, then organizing those ideas into categories or an outline. These activities strengthen comprehension, support retention, and give students a structured way to review and reflect on what they have learned. Homework that focuses on cooperative or collaborative learning allows students to engage with peers while deepening their understanding of the content. One approach is to assign partner or group projects where students research a topic and prepare a shared visual presentation or summary, which encourages teamwork and collective problem solving. Another option is peer review exercises, where students review each other's writing or problem solving work, either online or in journals. This not only helps students practice giving and receiving constructive feedback, but also reinforces their own understanding as they evaluate the work of others. Cooperative homework provides communication, collaboration, and critical thinking, while also giving students the opportunity to learn from multiple perspectives. You can even combine them all to make a menu that involves student choice. Let's look at an example. You could place the Marzano-inspired homework strategies all together in a homework menu style. This homework menu is designed to align with Marzano's research-based strategies and give students choice while supporting different learning needs. The first category, practice and effort, focuses on reinforcing skills and promoting persistence. Students can complete problems from the lesson, rewrite work to improve it, or label diagrams while reflecting on their accuracy. This helps students see the connection between effort and achievement and supports a growth mindset. The second category, note-taking and summarizing, emphasizes recording key ideas in a way that enhances comprehension and retention. Students might summarize a chapter in bullet points, annotate slides or class notes with other examples, or do a brain dump of ideas and then organize them into categories or outlines. These approaches encourage students to process information actively and make it their own. The third category, cooperative and collaborative, encourages students to engage with peers while building understanding. Options include working with a partner on research and creating a visual summary, providing peer feedback on assignments, or collaborating online to solve a problem or discuss ideas. Collaborative homework helps students develop communication and teamwork skills while reinforcing content knowledge. The key message is that homework doesn't have to be a one-size-fits-all. By offering multiple research-backed options, students can choose strategies that match their learning style, readiness, and interest, while still practicing important skills and engaging with the content meaningfully. Once more, which homework option from the menu do you think will be most effective for your students and why? And what is one small change you could make to your current homework practices to better align with research-based strategies? Stop the video to write down your thoughts. Possible answers for the first question: I think the practice and effort problems option will be most effective because it emphasizes purposeful practice rather than busy work. It allows students to apply what was taught in class while tracking their progress over time, which supports motivation and persistence. The choice-based homework menu will be the most effective for my students because it aligns to what we learned about homework being meaningful and differentiated. Giving students options increases engagement while still keeping the focus on clear learning goals. Possible answers for the second question: I could provide multiple homework options so students can choose the method that works best for them. Or I might incorporate more opportunities for students to reflect on their work and track improvement over time. Identifying similarities and differences is the next high-yield instructional strategy that we will discuss. Instructional strategy with the highest effect size is the identification of similarities and differences. The ability to break a concept into its similar and dissimilar characteristics allows students to understand and often solve complex problems by analyzing them in a simple way. Instructors can either directly present similarities or differences, accompanied by deep discussion and inquiry, or simply ask students to identify similarities and differences on their own. While instructor-directed activities focus on identifying specific items, student-directed activities encourage variation and broaden understanding. Marzano's strategy of identifying similarities and differences helps students deepen their understanding by actively analyzing content. When students compare and contrast ideas, classify items, or create metaphors, they are engaging higher order thinking skills. Instructors can scaffold this strategy using graphic organizers such as Venn diagrams, comparison charts, or matrices, which make patterns and relationships visible. For example, in a literature class, students might contrast two characters' motivations, or in science, they might classify types of chemical reactions based on comparable characteristics. Encouraging students to describe similarities and differences in their own words or generate analogies and metaphors strengthens comprehension and helps students transfer learning to new contexts. Using this strategy regularly supports critical thinking, retention, and the ability to make meaningful connections across content areas. The strategy of identifying similarities and differences can be applied across all grade levels, with examples tailored to student readiness and content complexity. In elementary school, students might sort animals by habitats or characteristics, or create a Venn diagram comparing two stories, helping them visually organize information and make connections. In middle school, students could compare historical events, such as causes of the two wars, using a chart to highlight key similarities and differences, which supports analytical thinking and understanding of cause and effect relationships. At the high school level, students might analyze similarities and differences between scientific theories or perspectives in literature, and even develop analogies to explain concepts. Across all levels, this strategy helps students recognize patterns, deepen comprehension, and strengthen critical thinking skills. Research also indicates that asking students to create a graphical representation of similarities and differences deepens understanding. A great strategy to use for comparison is the Venn diagram. The Venn diagram provides students with a visual display of the similarities and differences between two items. The similarities between elements are listed in the intersection between the two circles. The differences are listed in the parts of each circle that do not intersect. Here's an example for upper elementary or secondary students comparing and contrasting poetry and prose. This compare-contrast T-chart helps students organize similarities and differences between two items, in this case, eagles and owls, across clearly defined categories. Students identify relevant characteristics related to animal behavior, physical features, movement, symbolism, and record specific details for each animal. By organizing information side by side within each category, students can more easily analyze patterns, recognize shared traits, and distinguish key differences. This structure supports deeper understanding by moving students beyond listing facts to intentionally comparing ideas. As stated in the previous slides, a comparison chart is a powerful tool for helping students identify similarities and differences between concepts, objects, or processes. Students begin by selecting the items they want to compare and then decide on the key characteristics or attributes to examine. For each characteristic, they record how the items are alike and how they differ. This approach encourages students to think critically, organize information clearly, and make meaningful connections. For example, in a science lesson, students might compare two types of rocks based on color, texture, and formation process. In a literature lesson, they might compare two characters based on personality traits, motivations, and actions. By guiding students to analyze characteristics systematically, comparison charts support deeper understanding and make patterns or relationships between concepts more visible. Classifying is the process of grouping things that are alike into categories on the basis of their characteristics. The focus on classifying is on placing items into their appropriate categories and understanding why they belong in those categories. In this case, students have placed the pictures of animals that are vertebrates on the left and animals that are invertebrates on the right. Classifying using graphic organizers helps secondary students organize information by grouping items or ideas based on shared characteristics. This strategy strengthens critical thinking because students must analyze the attributes of each item and determine the best way to categorize them. Instructors can provide graphic organizers such as tables, charts, or concept maps to scaffold this process. For example, in a biology class, students might classify organisms into kingdoms based on characteristics like cell type, nutrition, and reproduction. In literature, students could group characters by role, motivation, or personality traits. After classifying, students should explain their reasoning either orally or in writing, which reinforces understanding and encourages them to make meaningful connections across the content. Marzano's strategy of creating metaphors helps students deepen understanding by connecting new or abstract ideas to familiar concepts. When students generate metaphors, they are actively thinking about similarities, relationships, and underlying patterns, which promotes critical thinking and retention. Instructors can encourage students to create metaphors in writing, discussions, or visual representations. For example, in elementary classrooms, students might describe the water cycle as a recycling system where water is always moving. In middle school, a student could compare a cell to a factory, with each part performing a different job. And in high school, students might explain economic inflation as a balloon that keeps getting bigger until it bursts. These examples illustrate how metaphors make abstract or complex ideas more concrete, memorable, and transferable. Encouraging students to create their own metaphors helps them internalize content and apply it in new contexts. Marzano's strategy of creating analogies helps students understand new concepts by connecting them to familiar ideas. Analogies encourage critical thinking by asking students to consider how two seemingly different things are alike, which deepens comprehension and supports knowledge transfer. Instructors can guide students to create analogies verbally, in writing, or visually. For example, in elementary classrooms, students might say, "A plant's roots are like straws that suck up water from the soil." In middle school, a student could describe an atom as like a solar system, with electrons orbiting the nucleus. In high school, students might compare the immune system to a security system that identifies and fights intruders. Additional examples include an elementary student saying, "A pencil is like a tiny factory that turns ideas into words." A middle schooler comparing electric circuits to a system of roads and cars traveling to different destinations. Or a high school student explaining, "Supply and demand in economics is like a seesaw balancing price and quantity." By creating analogies, students actively process content, make connections to prior knowledge, and are better to apply their understanding in new contexts. Let's reflect again. Which method, classifying or creating metaphors, could you try first in your classroom, and why? What is one small change you could make in your lesson planning to incorporate more opportunities for students to compare and contrast ideas? Stop the video to write down your thoughts. Possible answers for the first question: I would start with classifying because my students often need help organizing information, and grouping ideas will make it more manageable. Creating metaphors seems most engaging. It helps students make connections to prior knowledge and understand abstract concepts. Possible answers for the question number 2: I could include a Venn diagram or a comparison chart in lessons, or as homework to help students organize similarities and differences. I might add a short discussion prompt asking students to compare the day's topic to something they already know. Our final strategy of Marzano's 9 high-yield strategies is generating and testing hypotheses. Marzano's strategy of generating and testing hypotheses engages students in active learning by asking them to predict outcomes, propose explanations, or make educated guesses, and then test those ideas. This approach fosters critical thinking, analytical reasoning, and problem-solving skills. Instructors can model hypothesis generation by demonstrating how to make predictions based on prior knowledge, and then designing a test or investigation to confirm or refine those ideas. For example, in a science class, students might hypothesize what will happen to plants under different light conditions, and then conduct an experiment to observe the results. In math, students could predict the pattern of a sequence and then test it with additional numbers. In social studies, students might hypothesize causes for a historical event and examine evidence to support or refute their predictions. By generating and testing hypotheses, students learn to evaluate ideas critically, refine their thinking, and connect evidence to the conclusions. Now, let's look at some examples that can be utilized in your classrooms for generating and testing hypotheses. Strategy of generating and testing hypotheses engages students in higher order thinking by asking them to make predictions or propose explanations and then test those skills. For elementary, we can encourage students to make predictions before they test anything. Ask them to think about what they already know and what they expect to happen. Then have them observe carefully and record the results. This helps build critical thinking and observation skills, and it shows that it's okay if their prediction is different from the outcome. Learning comes from both. In middle school, you could have students make a prediction about how changing a number or variable will affect the outcome, then guide them to test it using calculations or models. This practice helps them see patterns, understand relationships, and strengthen their problem-solving skills. Remind them that testing their ideas is an important part of learning math. And in high school, we could ask students to predict how an historical event or decision might have affected a community or society. Then have them test their prediction by examining evidence, like primary sources or historical data. This approach helps students think critically and analytically, and it encourages reflection on how evidence can confirm or challenge their initial ideas. Problems involve obstacles and constraints. While engaged in solving problems, students must generate and test hypotheses related to the various solutions they predict might solve the problem. For example, an instructor might present students with a task that requires them to build something, like a bridge or a tower, with the constraint that they are only allowed to use limited or specific materials such as popsicle sticks, toothpicks, and rubber bands. Students would first need to 1. Identify the goal, build a bridge. Number 2. Describe the barriers or constraints that must be considered when trying to achieve the goal, which could be lack of study materials, quantity, or type of materials. Number 3. Identify different solutions for overcoming these barriers or constraints and hypothesize which solution is most likely to work. Number 4. Try their solution either in reality or via simulation. And number 5, explain whether or not their hypothesis was correct. Structured decision-making frameworks can help students examine hypothetical situations. A decision tree is a specific type of flowchart used to visualize the decision-making process by mapping out different courses of action as well as their potential outcomes. They are particularly useful for complex scenarios where there are multiple options and uncertain outcomes. To examine a hypothetical situation using a decision tree, students would first write the overarching decision they are trying to make. When to do your homework on the weekend, for example. Number 2, identify options. Friday after school, option 1, or Saturday and Sunday, option 2. Ask yes or no questions to find as many potential outcomes as possible to evaluate, and write the questions in the decision notes. Choose the option that aligns with the most favorable potential outcome. In a historical investigation, students outline a plausible sequence of events to describe what occurred during a past incident about which there are varying options. Historical investigation typically asks questions like what really happened at or what events led up to. People naturally engage in this type of investigation when they ask questions like, given the various theories, how were the pyramids constructed? Or, did George Washington really chop down a cherry tree? Historical investigations are done on events when there are no clear agreement on exactly what happened. There should not be any quick answers. Students will probably have to construct a possible resolution of conflicting scenarios and will need to be able to collect and analyze evidence to make a decision. They will probably need instruction on the difference between evidence and opinion and how to interpret different materials. Students could practice on a simple event in the news or in their community that makes hypotheses about what really happened. They use the following questions to guide their historical investigations. What historical event do I want to explain? What do people already know about this event? What confuses people about this event? What suggestions do I have for clearing up these confusions? And how can I explain my suggestions, or is there evidence that my scenario is plausible? Invention encourages students to create or design something new using the knowledge and skills they have learned. This strategy promotes creativity, critical thinking, and problem solving because students must apply concepts in original ways. Instructors can provide scaffolds such as guiding questions, criteria for success, or frameworks to support students as they invent. For example, at the elementary level, students might design a new playground using shapes and measurements learned in math. In middle school, students could invent a board game that teaches an historical event or a scientific concept, requiring them to apply content knowledge while thinking creatively. At the high school level, students might create a business plan, develop an engineering prototype, or write an original piece of literature that demonstrates understanding of key ideas. Using invention in the classroom allows students to synthesize learning, make meaningful connections, and engage deeply with content while producing something uniquely on their own. Instructors use experimental inquiry across disciplines to guide students in applying their understanding of important content. Experimental inquiry is a special kind of problem solving that is governed by rules of process and evidence. Experimental inquiry is built on empirical evidence, which is evidence that can be examined through the senses. Students can be taught the scientific method to understand experimental inquiry. The scientific method requires students to 1. Observe something of interest and describe what they observe. 2. Apply specific theories or rules to explain what they have observed. 3. Based on their explanation, generate a hypothesis to predict what would happen if they applied the theories or rules to what they observed. 4. Set up an experiment or test their hypotheses. And 5. Analyze the results of their experiment. Decide whether or not their hypothesis was correct and determine why or why not. This is a secondary example. And remember, experimental inquiry is built on empirical evidence, evidence that can be examined through the senses. So observe something of interest and describe what you observe. Apply specific theories or rules to explain what you have observed. Based on your explanation, generate a hypothesis to predict what would happen if you applied these theories or rules to what you observed. Set up an experiment or test your hypotheses. Explain the results of your experiment. Decide whether or not your hypothesis was correct and determine why or why not. This slide shows how experimental inquiry can be used beyond science classrooms. The focus is on students testing ideas, gathering evidence, and revisiting their thinking. In elementary math, students can compare different problem-solving strategies, such as number lines, drawings, or equations, and examine which approach leads to the most accurate or efficient solution. In elementary ELA, students can experiment with different story openings, gather peer feedback, and analyze which leads are the most engaging and why. In middle school social studies, students can explore how changing a law or policy might impact a society. They use historical or contemporary evidence to test predictions and support conclusions. In middle school math, students investigate how changing one variable, like speed, time, or cost, affects the outcome, helping them see cause and effect relationships through data. Across all examples, the emphasis is on using evidence to test ideas, not just finding a single correct answer. In high school ELA, experimental inquiry can be used when students develop and revise arguments. Students test different claims or types of evidence, such as statistics, quotes, or examples, to see how they affect the strength and clarity of an argument. By comparing drafts and evaluating feedback or rubric criteria, students analyze which choices are the most persuasive and why. In high school economics or civics, students use experimental inquiry to examine cause and effect relationships. They analyze what happens when one economic variable changes, such as taxes, wages, or interest rates, and observe the impact on supply, demand, or public response. Students use data, simulations, or case studies to test predictions and justify conclusions with evidence. These examples reinforce that experimental inquiry is about testing ideas with evidence, not just conducting lab experiments, and it supports deeper thinking across content areas. Let's reflect once again. Which types of hypotheses could your students generate in your subject area, and how would you guide them to test these theories? What is one concrete change you could make in your lesson planning to incorporate opportunities for students to generate and test hypotheses? Stop the video to write down your answers. Possible answers for the first one: science. Students predict how different soil types impact erosion, then design a model to observe and record results. In math, students could predict patterns in number sequences or the outcome of a probability experiment, then test their predictions with calculations or simulations. In social studies, students might hypothesize why a historical event happened and then test it by analyzing primary and secondary sources for supporting evidence. In an ELA in reading, students could predict a character's actions or story outcomes and then read ahead to compare their predictions to the actual events. Possible responses for the second question include prediction activities at the start of the lessons, followed by experiments, data collection, or test analysis of those predictions. Or design more inquiry-based labs, projects, or problem-solving tasks where students must propose and test their own hypothesis. Or add a reflection component where students revise their hypothesis based on results or evidence. Or plan discussion prompts that require students to generate hypotheses and support them with evidence before confirming or adjusting their ideas. We've covered a lot of content, so let's quickly review. As Marzano's final 4 high-yield strategies. Strategy 6, summarizing and note-taking, helps students capture key ideas and organize information in ways that support comprehension and review. Strategy 7, homework and practice, reinforces learning and effort by providing purposeful, skill-based assignments that allow students to apply what they've learned and track their progress. Strategy 8, identifying similarities and differences, develops critical thinking as students compare, contrast, classify, and analyze relationships between concepts. And finally, strategy 9, generating and testing hypotheses, encourages students to make predictions, test their ideas, and refine understanding based on evidence. Together, these strategies support deeper learning, help students make connections, and strengthen both comprehension and higher order thinking skills. We have now reached the conclusion of our exploration of all 9 of Marzano's high-yield instructional strategies. While understanding each strategy is important, effective implementation depends on careful planning, consistent practice, and thoughtful integration into daily teaching. Instructors should consider how each strategy aligns with their learning objectives, the needs of their students, and the structure of their lessons. By intentionally embedding these strategies into lesson plans, classroom routines, and student activities, instructors can create learning experiences that promote deeper understanding, critical thinking, and long-term retention. The ultimate goal is not simply to use the strategies in isolation, but to blend them purposefully so that students are actively engaged, supported in their learning, and empowered to apply knowledge in meaningful ways. As we move forward, reflecting on which strategies work best for your students and continuously refining your approach will ensure that these research-based practices have a lasting impact on student success. We hope you enjoyed this module, Marzano's 9 High-Yield Instructional Strategies, module for K through 12 instructors, Part 4. Please complete the Check for Understanding and the survey included in the Google Classroom. Thank you, and we look forward to providing continued support for your professional growth at University Instructors.